In previous session, we discussed about creating driver entry routine, and we have created a driver which loads and unloads using a user mode application, which is essentially a kernel mode service which runs on user mode, but it loads our kernel mode driver, which we have done in the previous session. So we loaded the driver, we created the driver entry routine, and inside the driver entry routine, we loaded our driver, and we called the unload function whenever the service wants to unload the driver. So that kernel mode service we made, which unloads the driver. In this session, we are going to develop a user mode service, and that user mode, not a service, I would say, we will develop a user mode application which we will use to communicate with our driver. So that user mode application will be sending some data to our driver, and we will be expecting some data from the driver. So there is to and fro communication between driver and user mode. In the previous session, we just created a kernel mode service which loads our kernel mode driver. That service is essentially a user mode application. The application is there which loads our kernel mode driver. That is the correct statement. So in this lesson, first we will study about IRP major request. So IRP major request. Once our driver device 6 wings device driver is created, we need to handle various requests made to the driver. These requests are known as IRP major request. So we have created the driver which is 6 wings. Now we want the driver to accept the IO request coming to it and send its data it wants to the user mode. So user mode will be sending some IO to our driver, and driver will be sending some IO, some results to those IO to the user mode that we want, and that is done through IRP major requests. So IRP major requests are some callbacks which are registered in the driver, which we will be registering in our driver itself. So once our device 6 wings device driver is created, we need to handle various requests made to the driver. These requests are known as IRP major requests. There are also IRP minor requests, which are sub requests found in IRP's stack location. We will study more about IO request packet in upcoming lesson. So for now, we will just have to know that user mode application will be sending some IO to our driver, and driver will be processing them and sending its data to the user mode. So back and forth communication will be there. The following code sets up handlers for these requests. So this code we will write in our driver. This code sets unsupported functions to our default handler and assigns specific handler for supported functions, supported operations like create, close, read, write, and device control. So these callbacks, we will call them, are registered in our driver. We will register these callbacks in our driver, and these IRP major requests will be called whenever an application sends our driver some IO. If the application wants to write to our driver, send a write request to our driver, then the IRP MJ write request callback, associated callback will be executed. Similarly, if an application wants to read some data from the driver, the dispatch read callback will be executed. by IO manager. First, we will write code and register these callbacks in our driver. So first, we will go to sixstrings.h, and on top we will declare two variables, uh, type def unsigned int uint. Unsigned int we will represent it as the uint, and we will declare another type def character pointer to a character we will call p char. Now in sixstrings.c we will uh, declare another variable which will be uint, and its name we will give uindex equals to 0. This will be helpful in traversing the unsupported functions which we will not be registering in our driver. We will not be registering all callbacks in our driver because there are many callbacks available. So only these 5 callbacks we will be registering in our driver. And we will be handling these 5 callbacks in our driver. And all other callbacks we will call unsupported function, which will automatically returns a value. So now coming back to the code, we will go to after the device creation above unload function. We will first reverse the unsupported function using index that we have defined equals to 0. UI index is greater than IRP mj maximum function UI index plus plus. Now p div driver object of major function UI index equals to dispatch unsupported function. So there are many major functions, maximum major functions. We will first so in 27, there are 27 major functions. So all 27 uh, we will not be registering the callbacks for. Only for a few of them we will be registering the callback for and capturing the IRP2, IRP4. So we have called for first we have registered dispatch unsupported function for all the IRP major requests. Now next we will register those 6 functions. So p driver object of major function IRP mj cleanup equals to dispatch cleanup. So IRP mj cleanup we have registered a callback for which we will be capturing p driver object major function IRP mj close dispatch close. This we have registered IRPMG close p driver object of major function IRPMG create dispatch create dispatch yes PAT create. Next we will register the p driver object of major function, we will register IRP MG device control dispatch IO control. Next we will register ARPMJ read P driver object of major function IRP MJ read dispatch read. Next we will register IRPMJ write. This is the last one. We will be registering P driver object of a major function IRPMJ write dispatch write. So these functions we have registered, these 6 functions. Now we have called back, we have the callbacks for these 6 functions and all the unsupported functions too. Now we will have to declare and define these functions. So coming back to 6things.h, we will first declare these callbacks. So anti-status this anti-status dispatch anti-status dispatch create p device object device object PIRP IRP. Okay, so it is a pointer, we will use a P in declaring anti-status dispatch cleanup P device object device object PIRP PIRP. Next anti-status dispatch close P device object is the parameter P device object. For every registered callback, IRP and device object are 2 parameters that every callback takes. P IRP P IRP anti-status dispatch IO control P device object P device object PIRP PIRP anti-status status dispatch read P device object P device object PIRP PIRP. Now for write, actually this for write operation we will for now handle write operations in 3 different ways. If a user mode application sends a write IO to our driver, and we will handle it in 3 different ways. So we define a variable use write function. So in the use write function, we will be doing the we will be handling the write requests from the user mode. Nt status status nt status dispatch write direct IO. There are three different ways our driver will handle the write requests from the user mode, and one of them is direct IO. P device object p device object PIRP PIRP nt status dispatch write buffer IO p device object device object PIRP PIRP nt status dispatch write and neither ther p device object device object PIRP PIRP. So these are three methods through which our device can handle a write request from the user mode that it receives. One is direct IO, buffered IO, and write neither. For all three of them, we will study in upcoming lesson and in this lesson too. So last one will be unsupported function. Status dispatch unsupported function p device object PIRP PIRP. So now we have registered the DISPATH unsupported unsupported function unsupported supported. This is capital. Okay. Now we have registered the dispatch functions. Dispatch functions are just named as dispatch because they handle the IO coming from the user mode, and they are used in registering the IRPs. So that's why they are dispatch functions. Whenever an IO request comes from user mode, these are invoked. And these are invoked whenever user mode requests some data from the driver too. So now we have declared these different dispatch functions that we have registered in our driver. Now we have to create definitions for them. We will create the definitions in a separate C file, which will be functions.c functions.c. So in this C file, we will first include wdm.h and include 6pins.h. Next, we will allocate the memory. For those, you will tell what memory these functions will be using, whether it is page memory or init memory. Pragma alloc text page dispatch create So all of the dispatch functions will be using a pageable memory. Pragma alloc text page dispatch cleanup. Pragma alloc text page dispatch close. Pragma alloc text page dispatch IO control. Pragma alloc text page dispatch read. Pragma alloc text page dispatch write 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 direct IO. Pragma alloc text page dispatch write buffer IO. Pragma alloc text page dispatch write NEIT write neither. Pragma alloc text page dispatch unsupported function. So we have made made sure that these functions use pageable memory. Now we will define these functions. So first we define the dispatch create anti status dispatch create p device object p device object PIRP PIRP and so these two parameters that have been defined will be not used for now in this lesson, will be used in upcoming lessons, like all of these callbacks that we have registered, right? These will be used in upcoming lessons. For now we will be not using any of these functions. These will be, for now, you can say, dummy functions, and they will not do anything. They just return the status successful, but we have registered them as callbacks. So these two parameters will be unreferenced for now. Unreferenced parameter device pdevice object unreferenced parameter PIRP anti anti-status anti-status equals to status, you will see double s return anti-status. We will also put a debug statement here. dbg-print dispatch create call \r\n. Next we will be doing the same thing for next function, whatever it is that we have registered, which will be a cleanup. So cleanup, all our unreferenced. Next will be cleanup. After that will be closed function, and this is also. Next will be IO control. IO control also will not do anything. Okay, will not do anything. Next will be read. Here too. Next will be write functions. So write direct IO, write buffered IO, write neither for all of them for now. In this lesson, we will not do anything. Buffered, write direct IO, write direct IO, buffer, and write neither. For unsupported function 2, we will not do anything actually. We just say that the function will be unsupported function. All the functions that our driver will be intercepting. The callback is registered, but the callback actually doesn't do anything for all of them. It just returns the status as success if it gets an IRP for that particular registered callback from the user mode. Okay. Now, coming to the notes, what do these functions that we have registered refer to? We set up handlers for create, close, IO control, read, and write operations in our driver. So we have set up those dispatch functions, those callbacks, that whenever user mode applications communicate with our driver, those callbacks will be called. These correspond to specific actions when communicating with user mode application. Create file, IRPMG create, close handle, IRPMG cleanup, and IRPMG close. Write file, IRPMG write, read file, IRPMG read, device IO control, IRPMG device control. So whenever user mode application calls this API create file, IRPMG create will be executed. Whenever user mode application close handle API calls, the IRPMG cleanup and IRPMG close handle registered in our driver will be executed. Whenever user mode application calls write file, the IRPMG write registered callback will be executed. Read file, IRPMG read registered callback will be executed. Device control, device IO control, IRPMG device control will be executed. One more important detail, IRPMG close is not called in the context of the process that created the handle. If you need to clean up resources related to the process, handle IRPMG cleanup as well. So both we have handled, both we have registered. In future we will be handling also those IRPMG cleanup and IRPMG close, as it is said in the notes that IRPMG close is not called in the context of the process that created the handle. So if we want to clean up resources, both IRPMG close and IRPMG cleanup both will be registered, and both callbacks will be executed when cleaning up the resources related to the process. When a user mode application uses these functions, it communicates directly with your driver. So as I said, user mode application will be using these APIs and directly communicating with our driver, and that user mode application will be written in upcoming lesson. You might wonder why these APIs refer to a file when they are in just for files. So why the file is used, write file, read file, create file. These APIs can interact with any device that exposes itself to user mode, not just files. So as the create file is not only used for creating a file, write file is not only used for writing a file. They are used for they are extensively actually used for communicating with the devices. So that's why these APIs are referred to as a file, write to the device, send the data to the device, read the data from the device. That will be the meeting. Next topic will be IO type and device initialization. Now, device object flag IO type. The line this line sets the IO type by adding IO type constant to the flags of device object. It sets the IO type flag to the device object. This defines how device handles IO operation. So whenever an IO request comes, this IO type flag will be defining how our device driver will be handling IO operation. So we'll be defining the IO type flag in sequence.c after registering the unload function. In here, we will define IO type flag p device object of flex is equal to IO type. So this flag will be defining how our device will be handling the IO operation, which is reading from the driver or writing to the driver. Next, we will be moving to the do device initializing flag. This line clears do device initializing flag, indicates that the device is no longer in initialization phase. This is usually done to inform the IO manager that the device is ready to handle IO requests. For devices created in the context of driver entry, this is not needed since the IO manager will clear this flag once the driver entry is done. However, if you create a device in any function outside driver entry, you need to manually clear this flag for any device you create with IO create device. This flag is actually set by the IO create device function. We cleared this flag here just for fun, even though we weren't required to. So this flag tells that the driver is not now in initialization phase and IO manager can send the IO requests to the driver. And we have to clear this flag, but IO manager will clear this flag if the device is created inside driver entry. But if the device is created outside driver entry, then we have to specifically clear this flag. We create this flag just we have to be clearing this flag just for fun. Device object flags flags and equals to do device initializing So now it clears this statements, clears the flag and tells the IO manager that our device driver is ready to, to accept the IO coming to the driver. Now IO handling part we will go to. Now in IO handling, if you have used the read write file and read file function, you know that you pass a data buffer to write to or read from a device. These buffers are sent to the device in an IRP IO request packet. So we used the write file or read file function in our user mode application. Then we know that these functions require a data buffer to write to or read from a device, and these functions are sent to the device in an IRP IO request packet, which we will be exploring more in an upcoming lesson. However, the IO manager uses three different methods to prepare this data before giving IRP to the driver. The method used affects how driver read and write function should interpret the data. So actually the IO manager uses three different methods to prepare this data from the user mode before giving the IRP to the driver. And these methods affects how the driver's read and write function interpret the data. Three methods are direct IO, buffered IO, and neither. So we will be defining these three methods now. So we have defined the IO type flag and use the write function in here. First, we will go and define go to the fixedStrings.h, and after a declaration on these two variables, we will define that we will be in upcoming lesson. For now, we will be studying about do direct IO. So we will define the use direct uh, variable. So this use direct method will be the first method that we will be studying about in the next lesson, and we have defined that in here. So after that, we will declare the three methods that can be used to handle the write requests coming from the user mode. So we first uh, check if the use direct method is defined or not. If defined, use direct, so it is defined above. If it is defined, then we will define it. Define the IO type. We will define the IO type. If the user mode sends IO operation to the driver, then the IO type will be the use direct, do direct IO, do direct IO, and we will also define the use direct function. So use direct function will be dispatch write direct IO. Hashtag define use write function to be dispatch write direct IO, and we will close. And so we have defined in the upcoming lesson, we will study about direct IO, what they are, how IO manager is sending the direct IO to our driver, and what the direct IO actually means for the driver. And next In the next upcoming lesson, then after studying the direct IO, we will study about buffered IO, and in the next upcoming lesson, we will study about neither, handling the write neither. If the user mode application sends a write request to our driver, then it will be handling in three ways: write direct IO, write buffered, and write neither. And according to the driver definition, if use direct is defined, it will be handling in write direct way, dispatch write direct IO. And if the uh, use direct buffer the IO is defined, then it will be handling in another way the write operation to the driver. And if the uh, write neither is defined, then it will be some other way. So all of three ways in which the driver can handle the write request from the user mode, we will be studying about them. So write request is nothing but that write request is just not a write request. It is saying write request means the user mode is trying to send a message to the driver using the write file API, and read request is say that the user mode is trying to read some data from the driver using the read file API. It is not that we are writing something to the file like a notepad. It is just sending the data from the user mode to the driver using write file API and receiving the data from the driver to the user mode using read file API. So for now, to study, there are three ways the driver, the IO manager handles the write request, which is sending the data from the user mode to the driver. The IO manager handles in three ways, which are these three, which we'll be studying. And next we will also study about read, how the user mode actually reads the data from the driver using read file API in upcoming lessons. So next we will define if the use buffered hashtag define IO type do buffered IO hashtag define use write function as dispatch write buffered IO hashtag and if next hashtag if define use NEIT here hashtag define use neither. It is not if nothing is defined actually. If nothing is defined, then we see if it is IO type is defined. If IO type is defined, then if IO type is not defined, if IO type is not defined, then we will define if we will define the IO type to be 0 and define the use write function to be dispatch write NEIT here. And then if IO type is not defined, it is not use direct, it is not use buffered, then we will define. If not defined IO type, then we will define IO type to be 0 and define the use write function as write neither. So IO type not defined, which means the IO manager says it is not, the driver is not handling the IO coming from the driver as use direct or use buffer. It will handle as dispatch write neither. So this is the code. Let's build it. See if it is building correctly. So it got built, and Yeah. So in the next lesson, what we will be studying is what is do direct IO, how the IO manager is sending the IO to our driver, and what actually is the do direct IO, and what we will be doing inside the the dispatch, right? Direct IO. So that we have registered the callback, right? If we go to the definition, here we will be defining what actually the this means, the direct IO means. Here also you can see, if you go to the definition, that it is this one, direct IO, buffered IO. These two will be studying in the next lesson.